the two other arms of our research. One is empirical work, experimental work on understanding how vision develops, and the other is on autism, how the developmental process can go awry. I find these two arms of our work very gratifying because they allow us to make contact with real lives, and not just make contact but actually improve lives. We have been very fortunate in identifying an experimental approach that is not only yielding very important scientific data, but in the process of conducting this research, we necessarily have to have a positive impact on many children's lives. It starts out by us going out into the remote rural regions of India, identifying children who have been blind since birth. But many of these are children who can in fact be treated, but because of poverty or because of lack of awareness of the treatability of the condition, or simply the fact that their villages are too far away from hospitals, these children stay blind, and many of them are doomed to stay blind for the rest of their lives. So there was a clear humanitarian need there of identifying these children and providing them treatment. That was the starting point of the project. We wanted to do something positive to help these children. But luckily for us as neuroscientists, in meeting that humanitarian need, we also have an unprecedented opportunity to understand how the brain develops with the onset of sight. So if you have a child who is 10 years old, who was born blind, has lived for these 10 years with his blindness, and you are able to initiate sight in this child surgically. From the very moment that the bandages come off, you can study how this child begins to learn to see. What is the status of their visual abilities in the first hour of sight onset, and how does that ability change in the days, weeks, months following that surgery. For neuroscience, this is like a gold mine of data, of very valuable data that we cannot get any other way. The only other circumstance where you would have these kinds of developmental data is when you're working with a newborn who has just been born and is now going through the developmental process. But a newborn, being a newborn, has many limitations in terms of how much they can comprehend, how much they can respond with. But in Project Prakash, which is the name that we have given to this effort, Prakash is Sanskrit for light. With Project Prakash, we have the opportunity to work with older children, say a 10-year-old child who has full linguistic abilities. So we can simply ask these children what they're experiencing, which means that the scope of the studies that we can do with these children is significantly enhanced, and we can ask them very, very sophisticated questions about their visual abilities, and we can also do studies of brain reorganization as we have been doing over the past few years, and the data are turning out to be really remarkable. They're giving us new insights into how much plasticity the brain has at different ages, and it's giving us insights into how the brain begins to be proficient at different visual tasks.